Another very interesting and very popular feature of Monyog is the query analyzer. Monyog analyzes three different things here: the slow query log, the general query log, and the sniffer data. We know what the general query log and the slow query logs are. Now, what is sniffer data? Sniffer data is the data collected by Monyog while sniffing either through the process list or through the proxy. So these are real-time data that are sniffed by Monyog. Of course, it'll only sniff if you ask it to sniff or if you set up Monyog to sniff. Now for demonstration, I'm going to pick the slow query log here because this is where we can find potential targets for optimization. So this is going to be analyzed now. Okay, we found one query here. Select actor ID, comma first name, comma last name from, let's get the whole query here so that I can see what's gone wrong with this query. Okay, so there is a select query with a where clause. Now I'm going to copy this. I want to execute on the server to find out what went wrong. I want to fix this query. So let me just do that for you now. Again, I'm going to use SQL log for finding out what could have possibly gone wrong with this query. This is the same query. Okay, I'm sorry, I'm going to go ahead and paste this. Okay, that's the query. Okay, this is the query that I just pasted. I'm going to go ahead and execute. This is a pretty big table with lots of rows, like 5.7 million rows in them, so it's going to take some time. I've also enabled the profiler of SQL log that could tell me details about, oh goodness, I know what's happened here. Looks like Monyog has just shot down the query that exceeded the 5-second interval that I had set up for demonstration purpose. Well, we need to go and disable it, otherwise we'll not be able to demonstrate. So, yeah, this was the setting. I'm going to go here. I'm going to remove those sniper settings, else it's not going to let me execute that query. How efficient is Monyog in shooting down queries? Very, isn't it? It doesn't even spare even one. So here I go, edit the server settings again. Yeah. I need to set it to, I need to disable the sniping options. Okay, sniffer settings. Yes, it was enabled, which is why Monyog shut down. I'm going to go disable it and do a save all on it. It's taking time to save the settings. It should be done within a second. Yep, completed. Now I'll be able to execute this peacefully. So execute. And as I was saying, it's a pretty big table, so it's going to take some time for executing. Okay, the results are here on our screen. Let's see what our profiler has to say about this query. Okay, it says a total time of 10 seconds was taken for execution. That's quite a lot. Okay. Scrolling further down, we can see that it has done a full table scan, which means looks like this query didn't use an index. And the explain result here confirms that we haven't used an index here. So the problem is we do not have an index here. What's the solution? Simple, have an index. We all know that, don't we? Now what I'm going to do is, I'm going to use a table which is exact copy of the table here. And this table was called actor without key. Now you know why it's called actor without key. Actor without key. Yes, I copied the contents of actor without key to actor and have already defined an index on it. The reason is, it's going to take a hell lot of time to add an index to that table. So I already added it for demonstration. You can see it. I've defined a primary key on actor ID. So this execution shouldn't be a problem. So this is the query, exact same query, but from actor table, which has the index defined. So I go here, execute. There you go. Before I could even complete the sentence, the results are out. And wow, look at the total time taken for execution. Under 1 second. Tremendous improvement in performance. And it hasn't done any full table scan. And the explained result confirms the use of the primary key. In short, we have successfully optimized the query. And where did we get this problematic query from? Monyok. That's where we got it from. This is how you can actually optimize your queries using the query analyzer of Monyok. There's another thing that I forgot to mention while I was talking about the query analyzer. It not only gives you a list of slow queries, it also gives you statistical data. For example, the total time taken, the average query execution time, the maximum query execution time, average rows sent, examined, details like that. And also the number of times that query was executed. Quite a bit of information when you have a lot of optimization to do. Another interesting thing about Monyok, the Monitor's Advisor. This is where you get a detailed view of your server. You get information about all your important metrics. All these are grouped for convenience this way. So if you want details about security, metrics about security, they are all grouped into security tag. And you have lots of these metrics under the security tab. I don't think there's anything we've missed out. No, we haven't missed out anything. Everything related to security is here. Everything related to InnoDB cache is here. So most of the important metrics are all shipped with Monyok. We also ship a set of best practices for each of these metrics. That is what we think are best and what the industry thinks is the best. But then if you want to go ahead and change that, you're most welcome to. You can change or say customize everything that you're seeing here. You can add new groups, you can add new metrics, you can do anything new here. Monyok by default alerts if the value of a certain metric goes beyond or below a certain threshold. Even these threshold values are customizable. Do not be afraid of changing or customizing any of the things available here because all your changes can be retrieved to its original state with just a click of a button. So that's how convenient it is to use the Monitor's Advisors. You get to see what's happening on your server. You can also get historic data. You can have the graph plotted. So there's quite a bit of information available here that could be used to tune servers. Well, that's about a little on how you can use Monyok to tune MySQL servers. As you've seen, Monyok is extremely easy to use and highly customizable. This might be the tool you're looking for. Do give it a shot. I'm going to now give the control to Cyan. He's going to speak a little more on Monyok.
Thank you, Shamali. A little more about Monyok in the sense that what we plan for the future. So Shamali just touched upon the Monitor's Advisors and how they can alert you on the different metrics. So each of those alerts are what we call events. Now, for the future, we plan to implement better event management. We understand that not every alert that you see is actually important to you. You'd like to ignore some of them. Monyok gives you a chance now to actually close an event so that you don't see it as a red or yellow dot in the interface and you can start off afresh. So anything that appears beyond that needs to be, it requires your attention. So that kind of a scenario. Also, a log of all the events that have occurred in the past so that you get a brief summary of activity on your server. Going over to the next slide. Advanced replication monitoring. Now MySQL gives you a lot of metrics. They say they give you slave behind master, seconds behind master. They can tell you the lag between a slave and a master. They can tell you if there's, in general terms, if the slave is in sync with the master. But how sure are you that your slave is actually in sync with the master? Because there's been many a times that the slave seconds behind master, the lag shows basically nothing, and we still have corrupt data on our slaves. This is the real life scenario that we had faced recently in our production servers, where the slave was not consistent with the master. So that's why we plan to implement a feature which actually goes ahead and uses table checksums and other such mechanisms to confirm that the data in the slave is consistent with the data in the master. Besides that, monitoring long locked queries. Now, you've Shamali already demonstrated to you the query sniping feature. Now, the query sniping feature kills down any query which would take a long time to execute. What we thought was, like, no matter in case like queries are slow, even if they are slow, they will come to a certain kind of a conclusion at one point in time. So you might not want to kill them. But queries which are locked will usually take up system resources, lock tables, and will not die off very easily. So monitoring long locked queries. The other day, one of a Monyog users, they sent up an email asking for alerts from Monyog for table sizes. He wanted Monyog to monitor table sizes. So what we went ahead and we planned it out, and now what we are going to do is drill down to every table in the database and start a monitor for that, so that the user knows exactly when a user can define thresholds for table sizes. So Monyog will send them an alert when a table size, say, grows beyond 1 GB, whatever. Coming back to Monyog's agentlessness, or the centralized architecture of Monyog, the biggest disadvantage of a centralized architecture is a single point of failure. You have Monyog installed on one system, and if that system goes down, all your monitoring data is lost. Now, that isn't the case in a distributed system. You have different production MySQL servers. You have agents installed on all of them. And if the monitoring server goes down, the agents are still collecting data from the MySQL production servers. Although the load on the MySQL server increases by a lot, I'm not going to give you specific metrics now, but it does increase by a lot. The data is still not lost. Even right after the monitoring server comes back up, you still have access to all the monitoring data. Now, with distributed control, we plan to alleviate the single point of failure that Monyog now suffers from. Okay, I'm not saying that Monyog is going to start having agents now. What I'm saying is this. So here's the deal. It would be nice if different running instances of Monyog could communicate with each other. Hypothetically, imagine you have 2 instances of Monyog running on your network, each monitoring a different subset of the MySQL servers under you. It would be nice if both those instances of Monyog actually communicate together and give to the user, that is you, a unified view of all the servers that are being monitored. And what happens when one instance of Monyog goes down? What happens if there's a hardware failure or Monyog itself crashes? Then the responsibility of monitoring the servers monitored by those instance that went down is transferred to the instance which is still running. That way, there is no single point of failure. So that is Monyog's future. We are continually developing. Okay, that way we are continually developing Monyog, and we haven't reached any saturation point yet. So there you can expect a lot in the future. With that, I should say thank you, and I'm going to pass over the control to Chirag, our moderator.